Hi and welcome to another new section, enhancing our components with pipes and directives. We'll leverage our knowledge in this section to take our components to the next level with the use of directives and pipes. Let's get started with the first video, directives in Angular. Angular defines directives as components without views. In fact, a component is a directive with an associated template view. This distinction is used because directives are a prominent part of the Angular core, and each needs the other to exist. Directives can basically affect the way HTML elements or custom elements behave and display their content. Let's take a closer look at the framework's core directives, and then you'll learn how to build your own directives later on in this section. As the official documentation states, the Ng4 Directive removes or recreates a portion of the DOM tree based on an expression. If the expression assigned to the Ng4 Directive evaluates to false, then the element is removed from the DOM. Otherwise, a clone of the element is reinserted into the DOM. For example, we could enhance our countdown timer by leveraging this directive, using these two lines of code. When our timer reaches 0, the paragraph that displays the time up text will be rendered on the screen. You've probably noticed the asterisk that prepends the directive. This is because Angular embeds the HTML control marked with the Ng4 Directive and all its HTML subtrees, if any, in an ng template tag, which will be used later on to render the content on the screen. Covering how Angular treats templates is definitely out of the scope of this course, but let's just point out that this is syntactic sugar provided by Angular to act as a shortcut to other, more verbose syntax based on template tags. Perhaps you're wondering what difference does it make to render some chunk of HTML on screen with ng4 rather than with hidden. The former will clone and inject pieces of templated HTML snippets into the markup, removing it from the DOM when the condition evaluates to false, while the latter does not inject or remove any markup from the DOM. It simply sets the visibility of the already existing chunk of HTML annotated with that DOM attribute. The Ng4 Directive allows us to iterate through a collection or any other iterable object and bind each of its items to a template of our choice, where we can define convenient placeholders to interpolate the item data. Each instantiated template is scoped to the outer context, where the loop directive is placed, so we can access other bindings. Let's imagine we have a component named staff. It features a field named employees, which represents an array of employee objects. We can enlist those employees and job titles in this way. As we can see in this example, we turn each item fetched from the iterable object on each loop into a local reference, so that we can easily bind this item in our template. A thing to highlight is that the expression starts with the keyword let. This directive observes changes in the underlying iterable object and will add, remove, or sort the rendered templates as items added, removed, or reordered in the collection. Besides from just looping all the items in the list, it's possible to keep track of other usable properties as well, as done in this HTML tag. Every property can be used in the same way, by us adding another statement after the declaration of the items. For instance, have a look at this HTML code. First or last is a boolean that keeps track of whether we're on the first or last item in our loop, should we want to render that item differently. It can be accessed with this block of code. Now let us look at the trackBy function. To explain what trackBy does, let's first talk about the problem it attempts to solve. The problem is that the data for Ng4 is pointing to may change. Elements may be added or removed, and even the whole list may be replaced. The naive approach to the adding or removing of elements is to carry out create or remove on the DOM tree for all those elements. If the same naive approach is used for displaying a new list, instead of the old list we use to display this, it'll be very expensive and slow. Angular deals with this by keeping DOM elements in memory because creation is costly. Internally, Angular uses something called object identity to keep track of every item in a list. trackBy, however, allows you to change from object identity to a specific property on your item. Let's add the code to illustrate this better. Here, index is a number to tell us what index we're on. It starts at 0. Even or odd is a boolean to indicate whether we are even on an even or odd index. The default object identity is good in most cases, but if you start experiencing performance problems, consider changing what property your item *Ng4 should look like, as done in this code. Notice how we've implemented track by here. Next, we have the else statement. Else is a new construct per Angular 4.0 and is a shorthand you can use to help you with conditional statements. Imagine you have this block of code. Our use case here is pretty clear. If we have a person set, then display its name, otherwise show a default text. We can write this in another way using else. What's happening here is how we define our conditional. We're saying, if person is set, then go ahead. If not, display the template no person. No person can be applied to a normal HTML element as well as an ng template. Let's now move ahead to explore about styling. So, there are three ways to apply styling in your markup: interpolation, ng style, ng class. Let's understand it with this simple expression. This version is about using the curly brackets and have them resolve what class or classes should be applied. This reads as if your item has a selected property, then apply the CSS class selected, or else apply empty string, which is no class. While this might be sufficient in a lot of cases, it has drawbacks, especially if more than one style needs to be applied, as there is more than one condition that needs checking. Interpolation expression is considered costly in terms of performance and is normally discouraged. Next option is ng style. As you've probably guessed already, this directive allows us to bind CSS styles by evaluating a custom object or expression. We can bind an object whose keys and values map CSS properties, or just define specific properties and bind data to them. Like we have defined here, font weight and my font weight. If our component defines the my color and my font weight properties with the red and bold values, respectively, the color and weight of the text will change accordingly. The directive will always reflect the changes made within the component. And we can also pass an object instead of binding data on a per property basis with this line of code. Similar to ng style, ng class allows us to define and toggle class names programmatically in a DOM element using a convenient declarative syntax. This syntax has its own intricacies, however. Let's see each one of the three case scenarios available for this example. So, this is the first example. For instance, we can use a string type so that if my class names contains a string with one or several classes delimited by a space, all of them will be bound to the paragraph. We can use an array as well, so that each element will be added. Last but not least, we can use an object in which each key corresponds to a CSS class name referred to by a Boolean value. Each key name marked as true will become an active class, otherwise it will be removed. This is usually the preferred way of handling class names. Here's an alternative syntax to ng class. In short, it's a comma-separated version, where it will apply a class when a condition is true. More than one class can be applied if more than one condition is true. It would look something like this if we used it in a more realistic scenario. See how we've implemented the span tag. The resulting markup could be something similar to this. If Jedi.side has the value light, then add CSS class light to the span element. Before we end this video, let's quickly go through a few more directives. The ng switch directive is used to switch templates within a specific set depending on the condition required for displaying each one. The implementation follows several steps, therefore 3 different directives are explained in this section. Here's all of this in a single example. The ng switch will evaluate a given expression, and then toggle and display those child elements marked with an ng switch case attribute directive, whose value matches the value thrown by the expression defined in the parent ng switch element. A special mention is required about the children element, marked with the ng switch default directive attribute. This attribute qualifies the template that will be displayed when no other value is defined by its ng switch case siblings matches the parent conditional expression. The parent ng switch parameter evaluates the weather forecast day context variable, and each nested ng switch case directive will be tested against it. We can use expressions instead, but we want to wrap ng switch case in brackets so that Angular can properly evaluate its content as context variables instead of taking it as a text string. Coverage for the ng plural and ng plural case sits outside the scope of this course, but basically provides a convenient way to render or remove template DOM blocks that match a switch expression, either strictly numeric or just a string, in a similar fashion to how the ng switch and ng switch when directives do.